Okay, so what does the word slope mean in the English language? Slope. Okay, downhill. Slant. Ooh, I like slant. That's a good one. The slant or what? The slant, or it's another word we kind of use for slope. Starts with the S as well, S-T. Steepness of a line. So that's the English language definition of slope. So what are some real life uses of the word? Real life uses of the word. Skiing. Yeah, the ski hills. We need to calculate right? We need a certain grade or slope, different difficulties, create different, have different slopes. So it's a black diamond, most likely it's going to be really steep. Green hills, nice and shallow. That's what I like. The bunny hill. Okay, what's another real life use of slope? Other than recreation. Any idea? Where would slope be useful? Ramps? What kind of ramps? Sure. Building a ramp for someone with a wheelchair? Overpasses. What do you mean? To go over? Okay. That leads to what I really want to get into, and that's the grading of roads. What does that mean? Grading of roads. Why would slope be important when it comes to making or paving roads? Okay. Well, let's think of it this way. Roads are usually built, the grading's kind of like this. That I over-exaggerated that here. So here's like center lane, right? Why would there be like that, a little bit of a slope towards the sidewalks? So the water can drain towards the sidewalks, so the drains. Yeah. So grading of roads is really important. Anything else? You can think of where we use grading, a certain angle to accomplish often drainage of water. Football fields. How about your bathtub? Anyone ever notice that? Again, for your water to drain, right? In fact, most piping in your sewer pipes, why would they need to be at a grade or have a slope? So it doesn't just sit there. We do not want your sewage to just sit there. And the smell comes up, it's not a good thing, right? We want it to drain towards the plant, basically, right? So there, in order for it, we basically use gravity to help move the water or whatever's in the pipes. Okay, and with that note, let's move on to slope. So slope is the same thing as rate of change. We talked about rate of change last unit, and they're identical. They're the same thing. And remember, slope is the vertical change or your rise over your horizontal change, your run. You have to rise before you can run. So change of y over change of x. Now this change of y, in order to find the change of y, it's basically getting the difference of our y values will give you that change. And so we can actually get this formula, y2 minus y1, for the change of y, divided by x2 minus x1, the change of x, where these are two different points. So we're dealing with 2 points, x1, y1, and x2, y2. So we'll have to call one point our first point and one point our second point. Can everyone grab your formula sheets? So your formula sheet, there we go. So formula sheets, I think it's the second one. All right, so in this unit, you're going to need to use your formula sheet a lot. So in the blue formula sheet, here we go. Slope equals rise over run, and m is equal to y2 minus y1 over x2 minus x1. So that's the first set of formulas we're going to work with. We're going to work with all of these formulas this unit, and so you will need your formula sheet if you don't have them memorized. Okay, so there you go. So you don't have to memorize the slope formula, you can actually just have it on your formula sheet. Okay, so back to an example. By examining the graph, you can determine the general slope. So what does a positive slope look like? Going up to the right. Yeah, it rises to the right. So we're going up and then right. A negative slope, going down, falls to the right. You should technically read a graph. I know it seems weird to read a graph, but read the graph left to right. So this line starts here and it falling, so we're moving towards the right. Falls to the right. Go left to right. Yep. Benz? No, if it's down to the left, it's positive slope. Right? That's why we always talk about moving towards the right. Zero slope. What does a zero slope look like? Straight across. And what do we call straight across? Horizontal line. Horizontal. And the reason why we're going to get a zero slope is there's our change of y over change of x. Our change of y is always 0. There's no vertical change over some number. And a 0 divided by a number is equal to 0. Undefined slope, what would that look like?
Straight up.
Straight up and down. And so therefore it's called a vertical line. And why is a vertical line called, why would it be undefined? Infinitely steep? Kind of. You can't, you're on the right track. Can't divide by what number? 0. So our change of y is going to be some number divided by our change of x is 0. And we can't divide by 0. That's undefined. The symbol for undefined looks like that. 0 with a vertical line with it through it. It's kind of cool because you can't divide by 0 and it results in a vertical line. So the symbol kind of like, I don't know, makes sense. I don't know. That's a symbol for undefined. So if you choose to take calculus, you'll see that symbol a lot. All right, next page. Use the slope formula to determine the slope of the line passing through each pair of points. So when we're given points, 2 points, we can use our slope formula to find our change of y over change of x if we don't have a graph. So remember our formula for change of y over change of x. The change would be the difference of y's. So y2 minus y1, and the change of x is the difference of the x's, x2 minus x1. And remember that is on your formula sheet, so you don't have to memorize. So our first goal is to figure out, okay, who's going to be our first point and who's going to be our second point. So who do we want our first point to be? Well, let's make it the first one we see. So this is always x and y, right? X comma y is our coordinates always. So all we got to do is add a little subscript to say who's going to be who. So we'll make the first one x1, y1, the first point. We'll make the second one x2, y2, the second point. And then really all it is plugging it into the formula. So the difference of the y's will be y2 minus y1. What's y2? 4. Y2 is 4 minus y1 is negative 1. What happens when we subtract a negative? Same thing of adding a positive. Okay, and that's a difference of our y's, 4 minus negative 1. Difference of our x's, x2 is 3 minus 2. See, the order matters, right? It's always if you're y2 minus y1, x2 minus x1. Okay, what's 4 minus a negative 1, or plus 5, divided by 3 minus 2 is 1, so it equals 5. If you can reduce your fraction, if it results like say 10 over 8, then you're going to reduce that to 5 over 4. We always reduce if needed. Okay, if the fraction needs to be reduced, we do. in your calculators, you can actually type this right here in all at once. But what do you have to be careful of when you type that all in Visi brackets. So if I wanted to type that, I can even use the minus the negative. So bracket 4 minus negative 1 divided by bracket 3 minus 2 bracket. So you have to wrap your numerator and your denominator. And then it gives you 5. Okay, so you can type it all in. You just need to make sure to have those brackets. All right, let's try the next guy. So you did not get that. Did you wrap your numerator and denominator? Here,
Negative.
2 negatives. We could also just go 4 plus 1. Because when you subtract a negative, it's the same thing as adding. So I'm taking away a negative. So you can turn that into a positive if you ever subtract a negative. It's the same thing as adding a positive. Okay, so when we have 2 points, we want to label which one's x1, y1, and which one's x2, y2. So start by just going x, y, x, y. It really doesn't matter who's 1 and who's 2. I like to be consistent. The first one I see, I call 1. The second one, 2. Okay, so we'll write out our formula. So we sub it in properly. Difference of our y, so y2 minus y1, or difference of our x's, x2 minus x1. And we just plug it in. So there's a pattern in that subtraction, you'll notice. 7 minus 7, negative 3 minus 0. So we just sub it in. Y2 is 7. There's y2. Minus y1 is 7. Over x2, negative 3. Minus x1, 0. So it's 7 minus 7. And negative 3 minus 0, negative 3. So 0 divided by a number, 0. So what kind of line would that be? It's a slope of 0. It'd be a horizontal line. In fact, the equational line would be y equals 7. So y is always 7. Okay, so when we want to plot a line, you always need at least a point, either 2 points or a point and a slope. So here I'm given a point and my slope. So our first step is to plot the given point. You have to have a starting point. So our starting point in this case is 4, 5. So I plug in x equals 4 and y equals 5. 4, 5. So plot our point 4 and 5. You don't have to write the coordinate, no. Our next step is to use our slope to obtain another point or more points. So let's talk about some general rules about slope. Slope is always rise over run. So rise is vertical over horizontal. So I'm going to give you some hints. So for the rise, positive is up, negative is down. For the run, positive would be right, which direction? For the run. Yeah, Luke? Right. And negative would be left. Negative would be left. So if my slope, your slope, you always want to turn it into a fraction so we can deal with the rise over run. So what's my slope here? What's our slope? Anyone know? Do you remember what M stands for? M stands for slope. Symbol M means slope. You think you'd call it like S or something, but no, it's M. So M is slope. So how do we change 3 into a fraction? Put it over 1. So now let's interpret our slope. Our slope is 3 over 1. So rise over run. So my rise is 3, a positive 3. My run is a positive 1. So if I'm positive 3, which direction am I moving for my rise? Remember, rise is up and down. So because it's a positive 3, we're going up 3, and run is left and right. But if I'm a positive 1, I'm moving right. So 1 right. Up 3, 1 right. So from our given point, we're going to move up 3. So up 3, right 1. And that's going to bring us to our new point. Up 3, right 1. Now, here's a little hint, or to help you get more points, because can I go up more? No. So I want to go the other direction. How would I get to another point that's on this line? Well, let's talk about this. Positive 3 over positive 1. Is that equal to negative 3 over negative 1? Why are they the same thing? Two negatives equal a positive. So we could also go, to get more points, we just basically switch both our directions. So we went up 3, right 1. We could also, the negative would be down 3, left 1. Yeah. So that would be when your slope is actually a negative line. One would be positive, one would be negative. So we can get more points by going down 3, left 1. Does that look like it's on the right line? Yeah. And we can get some more points. Down 3, left 1. Are you following that pattern? Down 3, left 1. And our last step, join the points. I would say 3 points is enough. So make twice, basically, because your given point you already have. And then just do it twice. And then you can just connect your points. If you really want to be like, make sure it all looks nice, you can do as much as you want. Down and left. So if I can't go up and right, I'm going to go down and left. You basically switch both the directions. Join the points. So this is where your ruler comes in handy. So grab your ruler, or you can use your calculator lid. When all else fails, let's do that again. And there you go. Not so bad? Now, you should extend your line. One thing I noticed from the unit exams is you guys tend to just connect the points you have, but the line actually continues. We're just plotting a couple points so we can draw that line. So it should go from end to end of the graph. Okay, let's try another one. So what's our first step? Plot -2 and +6. 1, 2, 3, 4, 5, 6. It has -2, +6. It's our first point. Now that that's plotted, what do we have to do next? Use our slope to get another point. So we need to interpret our slope. If our slope, it's already a fraction, so we're happy. Our rise is 1. If our rise is 1, which way? +1, we're going up 1. And if our run is +2, we're going right 2. So from our given point, I'm going to go up 1, right 2. Let's see if I can move this. Yeah. So up 1, right 2. Now, if I want to go the other direction, what would we do? Down 1, and left 2. We switch both of them. So down 1, left 2. Now, is that enough to draw a line? Yeah, that's enough to draw a line. If you want to just, if you're like, want it to look really good, you can do some more points. Down 1, left 2, down 1, left 2, down 1, left 2. And then just grab our ruler and we connect them. And there's our line. Pretty easy. So we'll be doing a lot of drawing lines this unit. Exciting. Okay, next page. Determine 3 other points on the line defined by the given point and slope. Okay, so we want to find 3 other points. So what's our first step? Put the coordinate on the graph. What's our coordinate? When x is 1, y is 2. So plot that guy first. Now that we have our coordinate, 2 over 1, we change our slope to a fraction. So which way are we moving? 2, up 2, right 1. So we're starting with 1, 2, and they want 3 other points. So we're going to go up 2, right 1. Up 2, right 1. So what point is that? What coordinate is that? X is 2, y is 4. Okay, let's do another one. Up 2, right 1. So that would be 3 and, do you notice a pattern? Notice here my change of y is 2 and my change of x is 1. That's our slope. That's the rate of change. Slope and rate of change are the same thing. Remember that from your exam? 2 over 1. So could I even just see the pattern? What would be another point? 4 and 8. So let's check. Up 2 over 1, yeah. Could we have gone the other direction? Yeah. What would our point be? What would we do? Down 2, left 1 is 0, 0. Could have been another point. So I just ask for 3 other points. You could add 0, 0 if you want. And then last, what do we have to do with these points? Connect them. I'll do it this way. I don't like the arrow at the end. No, no. I'm going to change mine. Done. Better. Okay. Before we get to the last question, if you're given a graph, so say, just looking at here, I had a graph, and I'm just going to draw a line really quickly. Make it red. So if I'm given a graph here, okay, and I ask you to find the slope, of this line. We need to figure out rise over run, right? So your first step would be to find 2 nice points. So a nice point basically touches like an x and a y on the grid. Does that make sense? It goes through a nice whole number for x and for y. So you find any 2 points. Does it matter which 2 points? No. So let's say these 2 here. Okay? So our goal is to go rise over run. So I count the steps down. So this is where, because our grid is always -10 to 10, scale of 1. We can just count. So if we make our triangle, it's all a matter of counting. So I would just go 1, 2, 3, 4, 5, 6, 7, 8. And 8, which direction did we go? Down. So that's a -8 because we went down. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, which direction? Right. So +12. So my slope would be, my change of x or y was -8 over +12. Would I leave my fraction like that? No, I just simplify it. So how can we simplify that? Divide both by 4. So divide negative 8 by 4, negative 2. 12 divided by 4, 3. So down to right 3 would have also worked. Down to right 3, down to right 3. And there's our slope. Okay, so we just have to, if we're going down, that's negative, right, positive. Okay, let's look at the last question. And then the rest of the time is for homework. A carpenter makes cabinets for a construction company and must meet a daily quota. The manager checks his inventory. After 4 days, he finds that there are 56 cabinets. After 9 days, the same carpenter made 126 cabinets. What is a carpenter's daily quota? What could we do to find it? Graph it. His daily quota. What's a quota? How many cabinets he makes a day. So what could you do to find how many cabinets he has to make in one day? 156 divided, or 56 divided by 4. Should that be the same thing as 126 cabinets in 9 days? Yeah, so let's check. Let's divide both. Okay, 56 over 4, is that the same thing as 126 per 9? Yeah, they're both 14. And so 14 what? Cabinets per day. 14 cabinets per day. Now they had to be the same. If they weren't, then there must have been some initial value involved. How does this quota relate to the slope of the line through the points? Okay, so let's find out. If we're given 2 points, can we use our slope formula? Yeah. x1, y1, x2, y2. So let's find our slope and see the relationship. So our slope is always equal to y2 minus y1 over x2 minus x1. What's y2? What do we label as y2? 126 minus 56 divided by 9 minus 4. All right, let's subtract. 126, remember you need invisi brackets if it's in your calculator. 9 minus 4 gives us 14. So what's the relationship between the slope of the line and his quota? What's the relationship? It's the same. It's the same, right? So rate of change is the same thing as slope. They're the same thing, right? The rate of change is the same thing as slope. Now this question, we were able just to go 56 divided by 4 only because this graph actually starts at 0, 0. At 0 days, he makes 0 cabinets. If there was some initial amount, in order to find the slope or the quota, we would have had to use the slope formula. You would have found that when you did 56 over 4 and whatever number over 9, they wouldn't have been the same. And so if that works out, if that happens, if these weren't the same, we'd have to use the slope formula to find the rate of change. Okay, as long as the relationship's linear. So today's homework is right here. We have about 40 minutes to work on it. Page 339. And there you go.